Okay, so where do I want to start? Okay, so last time we ended by talking about this function that, given the Celsius as input, it outputted the Fahrenheit, and that was the G function. And then what we did was we created the inverse function. Okay, we created the inverse function, which does the reverse process or undoes that process. So the input now in this one is Fahrenheit, and it spits out the Celsius temperature. So we use these symbols C and F to represent Celsius and Fahrenheit. But what I want to show you is that generically, what's normally done is, X is kind of the generic name for the input of any function. Okay, so if X is the input of G, what does X represent here? What does X mean? Yeah, and what is the input? What is the quantity? Celsius temperature, right? Celsius temperature. So we could write Gx equals 9/5. And so what do we do to Celsius temperature to get Fahrenheit? First we multiply by 9/5, the input by 9/5, and then add 32, right? Okay, and so then what's commonly done is we'll use X again in the inverse function. So we'll use X again to mean the input, but now this X takes on a different meaning. What does X mean in this context? This is the Fahrenheit temperature, right? So in the context of in the G inverse function, that will mean Fahrenheit, whereas X over here means Celsius. So this is a very common practice, where X is just always your generic symbol for input, but in the function and its inverse will take on a different meaning. Okay? So don't let that confuse you. So this is a very common way to do this. Okay? Questions about that? All right, so let's do an overview of the inverse here. Okay, so the first thing we want to say is this notation, it's like an exponent -1. It represents the inverse of f of x. Okay, that notation does not mean 1 over f of x. So it's not an exponent per se, right? It's not an exponent saying take 1 over the function, right? What does it mean? It means reverse the process or undo the process. Okay, so be careful for that. You don't to get the inverse function, you just don't take the function and take 1 over it. That's not what inverse is. Okay? All right, so perspectives and properties. So there's two kind of main perspectives about inverse function. One of them is that the inverse is the reverse process of the original function. Okay? Reverse process of the original function. So we have a function. All right? It's like a machine, right? So it takes input, it cranks on the input, and gives us output. So if we think of this as the reverse process, what are we thinking about? Well, it's the same machine, but instead we run it how? Run it backwards, okay? So that would mean that where would your input be? Your input is there, and it's like we're cranking the machine backwards, we're reversing it, and your output's there. Okay, so if that's the case, then what? The output of f of x is the same quantity as the input of the inverse. You see that? And then similarly, the output of f of inverse is the same quantity as the input of f. So the input and output switch. When you reverse the process, input and output switch. Okay, so in our notation, what I want you to do, here's the notation f of x. I want you to identify 4 different things as they appear in this notation. Identify the input and output of each function, the function and its inverse. So as it appears in this notation, can you identify the input and output of both the inverse, both the original function and the inverse? See if you can do it. So where does, say, the output of the original function appear? Where does the output of the inverse function appear? Where does the input of the original function appear? Does that make sense? You got 4 4 things to work on. Talk with the person next to you. These are the 4 things. All of them, all 4 things are represented somewhere in that notation. So we're figuring that out. So where is Ralph? You're up. You get to pick. You're the first one, so you're lucky. So which of the 4 do you want to tell me what it is? You can pick any of the 4. Tell me how it appears in this notation. So how is it represented, any of those 4 in this notation? Okay? It'd be what? So where do you see the input of F here? What's that? The X. That's it. So this right here is the input of F. Hopefully we all got that. All right? So hopefully that's the easiest one. Okay, next. Where is Nasser? Is Nas here? Nasser? Khan, you're up. Tell me anyone you want. You got 3 left. The output of which one? F or F inverse? F. So you're saying the whole thing represents output of F. Agree? Cool. All right. They took the easy ones. Where is Arturo? You're up again. I think I called on you yesterday or Monday. All right. So now you got to do either the input or the output of F inverse. Can you tell me one of those? Right. It's the same. It's also the output of F, right? So this whole thing again. So the input of F inverse is the whole thing. Okay, so what about the output of F inverse? Yes, sir, Evan. Just X. So that is the output of F inverse. This is really important when you get into a problem and you have these quantities flying around and they're asking you questions about different processes. You got to have this down, right? That's why we're taking the time. You really got to be confident what the different symbols represent in the context of F and in the context of F inverse. Any questions on that? Okay, do it again. Same thing, go. So 4 things: input and output of F, input and output of F inverse. How are they represented, or how do they appear in this? Where's Riley? Riley, you get to do 2. It's your lucky day. Which 2 do you want to do? Tell me. Any 2 you want. Nice and loud. Input of F inverse. Okay, but F of X isn't here. This is the notation we got for F inverse. So where do we see the input of F inverse there? So this is F inverse. So where's the input? X. So that's the input of F inverse. Okay, want to do another one? The output of which? That's it. All right, and then, good job. Where is Abdulaziz? Can you do the other two? Where do you see the input of F here? Where is the input of F represented? The whole thing? Yeah, the whole thing is the input of F. And so where do you see the output of F? X. Anybody have a question? Okay, so on page, you got something like this in your book. I think. I hope. Oh, maybe not. I thought this should be in your book. Oh, number 4 on page 103? Yes. Number 4 on page 103. So here's an example where you really need to identify what you see as input or output of the correct function in order to solve this. Okay? So page 103, number 4. Page 1. So 6, what does 6 represent? It actually represents two different things. What does the number 6 represent in this problem? It represents an input. Input of what? The input of F inverse. Do we have F inverse in here? No, we have the function F. So what is it relative to F? Output of F. So we're going to go to F and look at the output values and look for an output of F of 6. What does this whole thing represent then? Input or output of F or F inverse. Oh, forget about G for now. Just in terms of F, is it the input or output? No, it's the input of F. Corresponding to an output of F of 6. So that's why we practiced that previous slide. It gets confusing, okay? So that's the input of F when the output of F is 6. So what number is it? 2. Okay? But now 2 also is looking at G inverse. Go with red. So now we have G inverse of 2. So relative to the function G, what is 2? The input or the output of G? Output of G, right? It's switched, right? It's switched. This is the output of G. So we're going to look at the output of G of 2. And the whole thing is the input of G that would give an output of G of 2. So this gets confusing. That's why we took the time to work on this input-output stuff. Because you really got to practice. You're so used to this being input, right? But if in the inverse function, that's the output of the original function. And the whole thing is the input of the original function. Okay, does it help? Matthew, did you request that? Does that help? Okay, so I think we're gonna move on. Did these go pretty good? Anyone just want an answer? So any just answer request? What was the answer to F? People are saying 1, and someone said -2. I'll do it fast. So G of 2 is the input into G. Output of G is -1, but now that's the output of F, -1. So the whole thing is the input of F that would give an output of -1. So I think it's 1. Okay, last chance for questions on this. No. Okay, so the other perspective on inverse functions, so we talked about it's the reverse process. If it's the reverse process, then the input and the output get switched. The input of the one function is the output of the other, and vice versa. Another way to think of inverse is that F inverse undoes the process of F. Okay? And so they're similar but slightly different. Okay, this reverse versus undoes. So how would we symbolize undoes? So we got F, and we're going to put X in, and what's going to come out? How can we represent what's going to come out of this function? F of X is the output, right? Okay, so now if we put F of X into the inverse, if it undoes what this one did, what's going to come out of that? You're so smart. Okay, x, right. So what I want you to do is use function notation to represent this whole picture, the whole picture. Can you use function notation to represent the whole picture? See if you can do it. Can you write function notation, right? Function notation is something like this, right? H of, this is just an example, has nothing to do with this one. You know, H of a plus 100. That's function notation, right? That's function notation. So can you write function notation to represent this whole thing, that whole picture? Talk to the person next to you. See if you agree. Okay, Jordan, how'd it go? Any luck? Tell me what you thought. X is the input. But we want to write this in function notation, meaning an expression like, you know, h of, like I said, a plus 100. So can we use a function notation to represent it? Okay, who's next to him? In the blue shirt? No idea. Keep going down the line. Couldn't do it. Okay? Rachel. Okay, so what's first? What happens first? Sorry. Does f happen first or f inverse? F, right? So we put x into f and we get f. And then what happens? We're going to take that and do what? Put it into f inverse. You see? And that will give? Really important. Really important, okay? First, we put x into f, and we got its output. Then we took that output, and we put it into f inverse, and the result was x. So that's really important that you understand that. Okay, questions? So if f inverse undoes f, well, what about, so what we started with, what undoes f inverse? What undoes f inverse? Watch this. Ready? Took me about 15 minutes. Okay. Okay, so if f inverse undoes f, then f also undoes f inverse. Okay? Do it. Use function notation to represent that. So how would you do function notation? This should be easy now. How would you use function notation to illustrate that? Where's Taz? How'd you do?
I did
F of inverse of equals. That's it. What comes first? F inverse comes first. Put x into F inverse, and we get the output of F inverse. And then we put that output into F. It undoes what F inverse did, and it gives you back the original, what you had originally. Okay, any questions on that? So, in terms of if you start with a function and you want to find its inverse function, we want to think about it this way. So let me show you. Let's go back to our example, this one. So what was our original function g here? G was 5/9 x plus 32. Is that right? Did I have it wrong? 9/5? I just guessed. Is it right now? Okay, so let's we'll make this machine here. And make it plenty big. So we're gonna put x in, and now we're gonna like actually break down the guts of this thing. Okay, what happens first when so this is the G machine. So you're gonna put x in. What happens first to the input? First what? So what does this say to do to the input first? 9/5 of it. 9/5 times the input. And then what do you do to that next? You add 32 to that. Not just to the input, add 32 to that. That whole thing. And then we get out the output, g of x. Okay, so looking at those steps, if we want to build the G inverse machine, okay, so this is G inverse then. So now, the input into G inverse, we're also going to call x. That's what I was talking about at the beginning of class. We're also going to call it x, but it has a different meaning now, right? So if this undoes what this did, if it undoes it, then what will be first? You're going to subtract 32. See, it's going to undo it. So it's like going backwards to the machine. So the first thing you're going to do is you're going to subtract 32. And then what's the next thing you're going to do? Divide. You can say divide by 9/5 or multiply by 5/9. Well, let's say divide. I like divide by 9/5 because it's truly. So you're going to divide this whole thing, divide by 9/5. And you're going to get G inverse of x. So now that we've got these instructions, now we can write the function. So G inverse of x, what do you do first? Subtract 32. And then what do? Divide by 9/5. So by thinking about the process, the set of instructions that the original function does, and coming up with the reverse set of instructions, so it's like going backwards through the machine, how would you undo it? It can help you to find, given a function, find the inverse. Okay, so let's practice that. Any questions? Does that make sense? Let's get some good examples here. So this one, this one. Okay, so we'll change it to f of x. So this is gives the volume of a sphere. So just change the r to x. So what I want you to do is first write out the set of instructions that it does on the input. Then write out the reverse set of instructions, and then use the reverse set of instructions to write out the formula, the rule for f inverse. Okay? So first write out the set of instructions that f does. Ignore these questions. Yeah, no, I'm changing it. Ignore these. All right, so you're going to write out set of instructions. Correct? Write them out. And then, same thing, write them out. Set of instructions for f inverse. And then, based on your set of instructions, write the rule for f inverse. Go. It's the volume of a sphere. X cubed. It's right here. Okay, I'm gonna redo this on a different screen. If you feel like you're a pro, that was a piece of cake. This one's a little harder. 2x minus 5 all over 6. 2x minus 5 all over 6. Work on that one. If you're still on the first one, that's okay. Okay, so I put the solution up to number 1. First thing it tells you to do is to cube the input. Then, second thing, take that result, multiply it by 4/3 pi. So if we're going to undo that, we would first divide by 4/3 pi. And then take that result and cube root it. So there it is. You take the input, first divide by 4/3 pi, and then cube root it. Okay. Oh, was that for the pi? I was just checking you. Better? Yeah. Because it's, think of it, it's the whole idea of going backwards here. What did you do first? First you cube the input, and then you multiply that result by 4/3 pi. So if we're going to go backwards, what's going to happen? First we're going to divide by that. And then we're going to take that whole result and cube root it. So it's thinking about going, how would you go backwards? How would you undo what you did? So yeah, you cube root the whole thing. That's important. Okay. Who thinks they got the second one? Somebody new? Tell me your name again.
Joseph.
Joseph.
Alright, so first thing,
Multiply
multiply x by 2,
by 2.
and then this was I multiply the input of 5 and negative 5, 6.
That's not right.
Oh, so
What's the next thing you do after you multiply by 2?
I have this
Subtract 5.
and then
Divide by 6. So here's the... Each time you take the result of the one before. So then you subtract 5, then you divide by 6. So the inverse is going to be like what? What's first? Multiply by 6. Then add 5 to that result. And then divide that whole thing by 2. So we're going to first take the input and do what? Multiply by 6. Then add 5. Divide the whole thing by 2. So that's the process that undoes this one. So don't look for tricks. Go through the process every time. Don't look for tricks and just try to write them without thinking through these two middle steps. Okay. Write out the process of the original function, the undoing process of the inverse, and the final result. Any questions? Okay, so let's look at this this sheet. So I'm defining F as the number of people expected at a local concert if the temperature is X degrees F, Fahrenheit. And then G is the total revenue in hundreds of dollars at the concert if the attendance is X number of people. Again, see here's this use of X as a generic input, but with a different meaning depending on the context of the function you're in. Okay, so you're going to go through these expressions. So you might start by identifying input and output of F and F inverse. Identify the input and output of G and G inverse, meaning in terms of the quantities, the real world quantities that they represent before you start. And then you're going to go through these. Some of these make sense. Some of them don't make sense. Remember we said if you try to put, so what's the input into F? What's the quantity of input into F? Quantity. The number of people or temperature? Temperature. So if you try to put anything other than temperature into F, it's going to reject it. If you try to put volume into F, or profit into F, or height, it's going to reject it. The function of F is to take temperature and give you number of people expected at the concert. Okay? So that's what you're looking for, ones that work and ones that don't. Okay, again, you might start by identifying those quantities that are the input and output of F, input and output of G, input and output of F inverse, input and output of G inverse, and then see if you can figure them out. Okay, this is really good practice to see if you understand inverse and composition. Go. Some of them work, some of them don't. So for the ones that work, you're explaining the full meaning, right? For the ones that work, explain the meaning. For the ones that don't, explain why not. Okay? Great practice. This is, you don't have to copy this all down. Just it's posted in the exam 1 prep. Okay, this is posted. What's that? You don't. You're just saying, is it a valid expression, and what does it represent? I'm not giving you the rules of the functions. If you're right, you can't solve it. You can't get, if that really exists. You don't know what the number is, but you should know what it represents. Like a statement that says, this is the, whatever, this is the profit if 100 people attend, or something like that. Does that make sense? Okay, talk it over with the person next to you. Do as many as you can. Get through as many as you can. So the challenging ones are at the bottom. So you do one or two of those. F through J. F through J is where it gets challenging. Okay, we'll motor through as many as we can. A, valid or not? No, because the output of G is revenue, and the input of F is temperature. F says, nope, I don't take revenue, and it rejects it, no meaning. Okay, this one. Does it make sense? Okay, so how would you describe what X is in this equation? What is X? What does it mean? Tell me. X is the attendance? So X is the input of F, right? So what's the input of F? So it's a temperature. What temperature is X? What specific temperature is X? What's that? But how can we specify what temperature we're talking about in this? It's the temperature what? What's that? But we can say more than just it's a temperature. Yeah. It's the temperature at the concert, that's right. Alec. It's he says the temperature will give some expected attendance that will result in revenue of $100. So what is that, $10,000? Okay, so this is the temperature that you would expect a revenue then of $10,000. So that's what you want. So what about F inverse of 70? What does it represent? Is it a number of people or a temperature? Is this the input or output of F? It's an input of F. Input is the whole thing. It's the input of F. So it's a temperature. Which temperature is it? Temperature corresponding to? 70 people at the concert. Okay, definitely. So like I said, I posted this. Definitely work through these harder ones. Make sure you understand it and can do them. Okay, don't forget, test tomorrow. Study hard. Don't forget web work also. Friday morning web work.